Physics Part 219. Well, where x is the amplitude of the oscillation, the solution x is equal to x0 sine wt is used when at time t is equal to 0 the particle is at its equilibrium position, where x is equal to 0. Conversely, if at time t is equal to 0 the particle is at maximum displacement, x is equal to x0, and the solution is x is equal to x0 cos wt. The variation time of t of the displacement x for the two solutions is shown in the figure. In our previous chapters, it was shown that the gradient of the displacement time graph minus time graph may be used to determine velocity. Referring to the figure, it can be seen that at each time at which x is equal to x0, the gradient of the graph is 0. This applies to both solutions. Thus, the velocity is 0 whenever the particle has its maximum displacement. If we think about a mass vibrating up and down on a spring, this means that when the spring is fully stretched, the mass has its maximum displacement. The mass stops moving downwards and has a 0 velocity. Also from the figure, we can see that the gradient of the graph is at a maximum whenever x is equal to 0. This means that when the spring is neither under or overstretched, the speed of the mass is at a maximum. After passing this point, the spring forces the mass to slow down until it changes direction. If a full analysis is carried out, it is found that the variation of the velocity with time is cosinusoidal if the sinusoidal displacement solution is taken, and sinusoidal if the cosinusoidal displacement solution is taken. This is illustrated in the figure as well. The velocity of v is particle is given by the expressions v is equal to x0 w cos wt when x is equal to x0 sine wt. So there are sine values and cos values for the velocities. And v is equal to x0 w sine w into t when x is equal to x0 cos w into t. In each case, there is a phase difference between the velocity and displacement. The velocity curve is pi over 2 ahead of the displacement curve, and if the phase angle is not considered, the variation with time of velocity is the same in each case. The maximum speed v0 is given by v is equal to x0 into w. There is an alternative expression for the velocity. V is equal to plus minus w under root x0 square minus x square, which is derived on the forthcoming pages. For complete figure also shows the variation of the time and of the acceleration of a particle. This could be derived from the velocity time graph by taking gradients. The equation for the acceleration ra is equal to minus x0 w square sine w into t when x is equal to x0 sine w into t. And a is equal to minus x0 w square cos w into t, and when x is equal to x0 cos w into t. Note that for both solutions these equations are consistent with defining equations for simple harmonic motion. A is equal to minus w square into x. You can easily prove this by eliminating sine into w into t from the first set of the equation and cos w into t from the second. We have got an example for you, and we'll have more examples for simple harmonic motion. The example talks about the displacement and the simple harmonic motion. as we explain it in the next video.